problem is something like you have a n number of nodes and n minus number of links between them. So when you have n nodes and n minus n number of links between them, it ideally becomes a tree. And you have to find the number of, these are directed tree. So directed graph or directed tree. So you have to reverse some links such that all the nodes in the system is able to reach at 0. Right now here 0 to 1, it is from 0 to 1. We have to make it 1 to 0. Once you make it that, then there is 1 to 3 is there. 3 won't be able to reach at 0. So you have to reverse that as well. This red is the net reversal comes in the system. So you have to count the number of reds, number of red links required, number of red links which will be required after reversal of the links which are in opposite direction of the tree 0. So how to approach this problem? First we will create a graph, undirected graph. Though connections are directed, we will create an undirected graph and we will have a map which will be storing the direction of the link. A graph is undirected, but the map is directed. Map will have the direction recorded. So then you will start doing depth first search, breadth first search, starting from 0. You have a queue here. The queue will be inserted with the first element in the, starting from the 0, you will be following depth. So you have a visited array here, which is of size n. Just to, just initialized as 0, that means you will mark the 0th node as visited. Now you will go through these are the BFS statements. You will take the size of the queue, that is like one layer of breadth. And then while that layer is incomplete, you will fetch each item from the queue. You will iterate through its neighbors. If the neighbor is visited, you will continue. If neighbor is not visited, you will mark it as visited. And you will check the neighbors that from the current position, that means temp, to the neighbor, that means IT. If MP of temp and IT is there, that means that link is directed away from the 0. So you have to count it as a red link, because you have to reverse that link. That link is directing away from 0. We started the depth first search from 0. So that link is going away from 0, that you will be recorded as count. Count will be incremented. Then you will be enqueuing that node for the breadth first search in the next iteration. Finally, once the breadth first search is over, you will have the net count that you will return as a solution. So let us see whether it is giving the right answer for